if I'm looking at this problem here and I'm trying to decide if these two triangles are similar, I know that I can do either angle-angle similarity or side-angle-side similarity. Now, I don't have any side lengths marked, so I know side-angle-side is pretty much out of the question. But maybe angle-angle is what I can do. So if I'm looking at what I have, I know that these two angles are congruent to each other. 32 and 32 are congruent to each other. So I know that angle J is congruent to angle X. All right. Well, I definitely know that 52 and 96 are not congruent to each other, but maybe I can do the triangle angle sum to figure out if angle P might be congruent to angle V. So let's try that out. So I need to figure out what angle P is. So I'm going to do 180 minus 32 minus 52. And when I do that in my calculator, I get 96 degrees. So now I know that I have two angles. Angle J is congruent to angle X, and angle P is congruent to angle V. So I have satisfied the angle-angle similarity condition. So I can say that these two triangles are similar by angle-angle similarity. And if I were going to write out the triangle similarity statement, I would write triangle, and you can write the first triangle in any order you want. So I'm going to write JPO is similar to triangle. Now, if I write J first, I have to write X first because I need to write them so that the angles are corresponding with each other. If I wrote P second, I need to write V second. And then that leaves me with K for the third one. So that would be my similarity statement. Let's look at this next problem. Are these two triangles similar? Well, if I'm looking at what I have marked, I only have one angle marked as congruent, and I don't even know what that angle measure is. I just know that from the marking in the diagram, they are congruent. So angle U is congruent to angle F. But since I don't have any angle measures, I can't use my triangle angle sum to find any of the other missing angles. So angle-angle is out of the question because I only have one angle. But I do have some corresponding sides that are marked. So I've got my smaller side, which is 14, that's UT, and that's going to correspond with the smaller side in the other triangle, which is 44.8 IF. And then I've got UQ is corresponding with FK. Then I just got to see if they're in the same proportion, or if they're proportional. Are they in the same ratio? So I am going to do 44.8 divided by 14, and I'm going to see what that gives me. So I do that in my calculator, and I would get 44.8 divided by 14 gives me 3.2. Okay, now I'm going to do the same thing with the other pair of sides. So I'm going to do 64 divided by 20. Remember, if I'm putting this triangle on top in the first fraction, I have to put it on top in the second fraction as well. And if I do that, I also end up with 3.2. So that means that I've got the angle in between two pairs of corresponding sides, and those sides have the same ratio. That means that this would satisfy side angle side similarity. There's a very important thing here in side angle side similarity. Notice the A is between the two S's. That means the angle has to be between the two sides. So when you're marking your diagrams, you need to make sure that that angle is the angle that those two proportional sides form. Okay, next one. I do not have any angles marked, whether marked by having a number or marked by having a congruent symbol. None of them are marked, but let's just take a look and see what's going on with the side lengths. Maybe that'll tell me enough about the two triangles. Okay, so I've got my shortest side here, which is 18, and that's going to go with my shortest side here, which is 90. And then I've got my middle side, which is 44, and that's going to go with my middle side, which is 202.4. And then longest side would correspond with the longest side. So I've got my triangles marked, so I have my corresponding sides marked in the same color. Now I'm going to see what they equal, what the ratio of each of them is, because that's going to tell me what I need to know about the triangle. All right, so I'm going to start with my yellow sides. I'm going to put the bigger number on top, 90 divided by 18. So I'm going to always put this triangle length on top. 90 divided by 18 gives me 5. Okay, now let's do the ones that are marked in green. So I'm going to do 202.4 divided by 44. And if I do that, I get 4.6. Uh-oh, that is not the same as 5. So that means that no matter what, these triangles are not similar. Here are your right side notes for today. We've learned 2 shortcuts or 2 conditions for similarity. The first one is angle-angle similarity, and we can kind of abbreviate that by writing AA similarity or AA tilde. And this is what happens when you have 2 pairs of corresponding angles that are congruent. If I know that 2 pairs of corresponding angles are congruent, then my triangles will be similar. So that's my first condition for similarity, my first shortcut, angle-angle similarity. It might be that you have to use the triangle-angle sum theorem to get that second angle, but as long as you have 2 of the 3 angles marked and you can prove that 2 pairs of them are congruent, you can use this shortcut or this condition for similarity. And then the other condition for similarity is side angle side similarity. When you have 1 pair of corresponding angles that are congruent and the sides that create those angles are proportional, so they're in the same ratio, then your triangles will be similar. So here's the second condition or the second shortcut we have for showing that 2 triangles are similar.